Today we are going to study Chapter 3, the electricity power industry. In this chapter, there are 12 sections. Section 3.1, the earlier pioneers. 3.2, the electric utility industry today. Section 3.3, polyphase synchronous generators. Section 3.4, cathode efficiency for heat engines. Section 3.5, steam cycle power plants. Section 3.6, combustion gas turbines. Section 3.7, combined cycle power plants. Section 3.8, gas turbines and combined cycle cogenerations. Section 3.9, base load, intermediate, and peaking power plants. 3.10, transmission and distribution. Section 3.11, the regulatory side of electric power. Section 3.12, the emergency of competitive markets. In this lecture, we will discuss the first 4 sections. The section 3.1, the early pioneers. This section is a self-study session. I will not present any content of this session. This slide shows you the major events starting from the year 1800 to the year 2001. And you will read the textbook and then understand the content. This section will be studied by yourself. Now let's talk about the section 3.2. The electric utility industry today. Electric utilities, monopoly franchises, large central power stations, and long transmission lines have been the principal component of the prevailing electric power paradigm. Figure 3.1 shows you the overall utility generation, transmission, and distribution system. At the site, the electricity generated at a central power station is almost always three-phase alternative current power at voltages that typically range from about 14,000 kilowatt to 24,000 kilowatt. At the side of generation, transformers step up the voltage to long-distance transmission line levels, typically in the range of 138 kilowatt to 765 kilowatt. These voltages may be reduced for regional distribution using sub-transmission lines that carry voltage in the range of 34.5 kilowatt to 138 kilowatt. When electric power reaches major load centers, transformers located in the distribution system substations step down the voltage to levels typically between the range of 4.16 kilowatt to 34.5 kilowatt. Distribution feeders lines carry power from distribution substation to the final customers. On power poles or concrete pad mounted boxes, transformers again drop the voltage to the levels suitable for the residential, commercial, and industrial uses. The voltage mainly is in the range of 120 volt to 600 volts. Section 3.2.1, Utilities and non-utilities. Entities that provide electric power can be categorized as utilities or non-utilities, depending on how their business is organized and regulated. Based on the ownership, these entities can be divided into 4 categories: investor-owned utilities, federally owned utilities, other publicly owned utilities, and rural electric cooperatives. Investor-owned utilities are privately owned, with stocks that is publicly traded. They are regulated and authorized to receive an allowed rate of return on their investment. Investor-owned utilities may sell power at a wholesale rate to other utilities, or they may sell directly to retail customers. Federally owned utilities produce power at facilities run by entities such as Tennessee Valley Authority, the Bonneville Power Administration. They produce power. They sell the power on a non-profit basis, mostly to federal facilities, publicly owned utilities, and cooperatives. Other publicly owned utilities. They are state or local government agencies that may generate some power, but which are usually just distribution utilities. Rural electric cooperative. They were organized and financed by the Rural Electric Administration in the area that are not served by other utilities. Non-utility generators. Non-utility generators are privately owned entities that generate power for their own use and or for sale to utilities and others. They are distinct in that they do not operate transmission or transmission system and are subject to different regulatory constraints than traditional utilities. Section 3.2.2 Industry Statistics. The energy going into power plants is referred to as primary energy, to distinguish it from end-use energy, which is the energy content of electricity that is actually delivered to customers. The numerical difference between primary and use energy is made up of losses during the conversion of fuel to electricity, losses in the transmission and distribution system, and energy used at the power plant itself for its own needs. Less than 1/3 of primary energy actually ends up in the form of electricity delivered to the customers, which implies that 2/3 of energy has been wasted during the conversion process. The electricity equation has 2 sides, the supply side and the demand side. Both are critically important to understanding the electricity, the industry. The end-use side of electricity is usually divided into 3 sectors: residential, commercial, and industrial. As we can see from this graph, this graph shows the electricity flows as a percentage of primary energy. The primary energy include coal, natural gas, nuclear, and renewables. Coal is the dominant fuel, accounting for 52% of all power plant input energy. Nuclear is 21%. Natural gas accounts for 15%, and the renewable energies, including hydro and geothermal, is about 9%. Note that the petroleum is a very minor fuel in the electric sector. It's only about the 3%. And we can see during the conversion process, the conversion losses is 65.3%, which means only 34.7% energy from the primary energy has been converted into the electricity. And the plant will use 1.7%. The generation plant will use 1.7% of electricity generated. And the transmission and distribution loss is 3.1%. Therefore, only 31.8% will be used to serve the end use customers. The residential, among these end use customers, residential utilize 10.6% of electricity, and commercial accounts for 10.5% of the total end use energy, and industrial is 8.8%, and direct use is 1.8%. Now this slide shows the energy source for electricity generation by the region. The distribution of power plant types around the country is very uneven. The Pacific Northwest generates most of its power at large hydroelectric facilities owned by the federal government. For example, the Bonneville Power Administration is also on the major hydro facilities and produce significant amount of the hydropower in this northwest region. Coal is dominated in the Midwestern and the South states, especially the Ohio, the West Virginia, Kentucky, and the Tennessee. Texas, Louisiana, Oklahoma, and California are driven significant fractions from the natural gas. And little oil fire generation is tend to be in Florida and New York. This slide shows the retail sales of electricity by the end use. In terms of kilowatt-hour sales, it's self-generated on-site. The building sectors accounts for 2/3, which is 26% is used for residential and 32% for commercial. This together are mainly the building sector electricity usage. The industrial users only use 29% of the total electric generation. In the residential sector, the major usage are spread over many miscellaneous loads. The single largest ones are air conditioners and the refrigerators, so used for the cooling and for the refrigerators. In the commercial sector, lighting is a dominant single load, and the cooling is being the major importance. This slide shows the California power demand on a hot summer day. As we can see, the bottom load is the agriculture load, and on the top of the agricultural load is industrial load. The industrial and agricultural load are relatively constant. In terms of the peak demand, during this peak demand, 3/4 of the load are the air conditioning and the lighting, which account for the 40% of the total peak demand. So, better building with greater use of natural daylighting and increase attention to reducing afternoon solar gains greater use of natural gas-fired absorption air conditioning systems, and load shifting by using ice made at night to cool during the day that could make a significant difference in terms of the power plants that are needed to meet the demand. So through these activities, we can effectively control or reduce the peak demand, therefore can reduce the number of the power plants to be built. Figure 3.7 shows the state-by-state average retail price of electricity. The average price of electricity in 2001 ranged from a low 4.24 cents per kilowatt hour in Kentucky to high of 14.05 cents per kilowatt hour in Hawaii. The average price across the nation is 7.32 cents per kilowatt hour. Among the coterminous states, California electricity was the most expensive in 2001. The retail price in California is 11.78 cents per kilowatt hour. Because mainly California uses natural gases, and using natural gas to produce electricity is very expensive. This picture shows the average price change charged for residential, commercial, and industrial customers over the time, starting from the 1960s to year 2000. Over the 40 years, how the retail price to the residential, commercial, and industrial fluctuate during the time. The industrial facilities are typically charged on the order of 40% low for their price than the commercial and residential. Industrial customers usually have a uniform energy demand, can be served by large part of less expensive baseload plant, such as a coal, and they can run more or less continuously. And the nuclear power plant are also usually used to serve the industrial load. The distribution system serving utilities are more uniform loaded. They try to reduce costs and certainly the administrative costs to deal with customers, billing, and so on and forth or less. So therefore, the residential and the commercial price are usually cost more. On one side, they are usually account for the peak load demand that require using more expensive power, such as produced by petroleum and produced by natural gas. That is one reason to cause the price for residential and the commercial high. And the other side, the local utilities to deal with the residential and the commercial customers require more administrative cost, and also they need to build the billing systems to help to collect the funding, collect the fee from residential and the commercial customers. That also costs more. Therefore, the retail price for residential and commercial customers are higher than industrial customers. By now, we finished section 3.2.